Okay. People will be start joining soon. I don't
Yeah,
see viewer
let's wait for
yet.
the minute.
I
Yeah.
see now. I see now. Hello everyone. Hello everyone. Good morning, good afternoon, good evening from the different time zones. We'll be starting in few minutes, like couple of minutes, like it's 12 EST. We'll start in 2 minutes. Because I see people have been started joining, and we'll be waiting for one more couple of minutes. Super excited for this workshop because we are going to walk you through the presentation and then coding. So we are going to explore like how secure computation works using DE and how you can store that securely on IPFS. So yeah, we'll be waiting one more minute and then we'll start. Meanwhile, let me give you my introduction. So my name is Nidhi Nakrani. I'm the DevRel at Metis, and we have Thiru, DevRel from Metis here with us as well to give us more information like for on the T or on the use case part of the T. So we welcome all of you. I know you guys are joining us from a different time zones, from a different part of world. So we are super excited and happy to have you here. We hope that you get something useful from this session. Um, Before I start, uh, Atir, would you mind sharing some little information on hackathon that's going on Hyperion ecosystem?
Sure. So we have the HyperHack, and so we are in the middle of the dev stage. So we had an idea turn stage where we had amazing ideas in our forum, and we have around 120 ideas have been approved and started building. And we are currently in the middle of the building phase, the development phase. And actually, our development phase extends till August 7th, where the project submit, that is the final deadline for HyperHack. But we also have a stress testing phase, which starts on July 15th. So July 15 is one of the important date for HyperHack because not only the stress testing phase started. So to give more context on stress testing, it is basically community testing where you can get people from Hyperion community, LazyEye community, Metis community to test your product and get feedback. You can still iterate on it. If someone finds a bug, someone give you some suggestion, you can have this opportunity to get the initial users. Let's say like initial 10 user, initial 20 user, or initial 100 user. So this is the perfect opportunity for the projects. So uh, the feedback for the hackathon projects is really essential. So feedback from mentors are great. How about feedback from the users themselves? So that is the perfect opportunity for projects building on HyperHack to utilize during the stress testing phase. So stress testing phase starts on July 15 and extends till August 7, which is the deadline of HyperHack. And as I mentioned, July 15 is the important date, not only because of the stress testing phase starting, there is also the start of Spotlight campaign. So the Spotlight campaign is a marketing campaign for the hackathon projects themselves. So we are providing an opportunity for them, not just to build a hackathon project, but also to create a product by marketing it. So all the hackathon projects have this issue with marketing because that is something only products that's after like they complete the dev stage completely and then just start. But for a change, we are having this opportunity that we are providing for the hackers. That we have also provide with like $500 funds for them to market. We provide them materials for them to and like learn marketing because like all the hackathon participants or devs, like all of them, So most devs don't have like idea for marketing. So this is an opportunity they have. They can learn marketing, but we also like suggest them to hire a marketer because we have a marketing guild solely focusing on marketers or non-technical people. So marketers, BDs. There's a lot of people in our forum, mostly dominating, if I say. So you can get help from them. You can get them into the team. So this is a perfect opportunity to collaborate. Someone like really care about your product. They like you. They want to contribute in a non-technical way in marketing, social media campaigns, getting initial users, getting test users, or running like a community campaign. So you can get them in, and you can you can get this $500 credit, which you can able to use for any of your campaigns. So that's like completely up to you. In order to qualify this, first thing you have to do is submit to the a form that we are circulating in the forum. I'll also drop it in the comments here. So if anyone just got to know about this, this is the perfect time. Just go and apply for it. And so the deadline for that is July 7th. So we just have like 4 more days. So without further ado, just go and apply for it, and we will announce it before July 15, the qualified projects for the Spotlight campaign. And what are the criteria for the qualification is the progress you made within the hyperhack period, how much you have built after the ideathon phase, like how much progress you have made, and your use case on Hyperion or building on Laz AI. So how you utilize the Alith framework. So these are the major criteria along with your marketing plan. So how good your marketing plan is. So if you don't know about this, you can read about it with the like learning materials we are providing in the forum. You can like reach out to any of our team. If you can't find it, we'll be happy to help you with it. So these are the major events for the upcoming HyperHack submissions. One is the Spotlight campaign, as I mentioned. Another is stress testing phase, and we are also nearing the deadline. So these are the major updates from our side for the HyperHack. At least uh, we can continue the session.
Yeah. So thank you so much for sharing all the important details about the HyperHack, and I hope that projects are seeing us and like right now the session would that this would be like very helpful for them. So further ado, let's get started. So um, this workshop is particularly focused on TEE, Trusted Execution Environment. So we're gonna see what is TEE and how we're gonna store, how we're gonna use Alith. I mean, this is the feature of Alith we have. So how we're gonna use this feature and how we're gonna store data securely on IPFS using TEE. So, all right, so let's get started. So TEE, let's get just started with basics. So it's like a secure black box inside your computer CPU. So let's say it lets us process sensitive information in a way that is completely isolated. So even from the operating system. Okay. So yeah, I mean, not even root access can peek inside it. So it's like very secure environment, like completely isolated. So this is super useful in cases where data privacy, integrity, and security are top priorities. So think AI models, finance, or decentralized governance. So this is that's how I mean the basic of TEE, and the key features are oh my god, one more uh, slide ahead. Okay. Key features include encrypted memory, like only accessible within the TEE, and I mean now like Alith provides a developer friendly way to interact with TEs, so without needing to manage all the low level hardware's API. Like it gives the features as like encrypted memory, tamper resistant during runtime, like um, key management as well, like generating and using cryptographic keys inside enclave, and can produce remote attestations, like the proofs that computation was done securely, and basically the proof of generation to um, attest the integrity of data processing, isolation of course, and confidentiality, as it's a secure environment. So use cases is like verifiable computation, confidential data processing, web3 proofs for zk bridges as well, secure ml inference. I see comment. All right. Okay, so uh, Thiru, would you mind like sharing us the use cases of the like
Yeah.
if we talk about let's say that in Hyperion project, like we have the three tiers, I mean the three tracks, right? So in each of them, like how would we or you like we use TEE in what kind of use cases, in what kind of projects you can use this trusted execution executable environment?
Yeah. So for beginners, there's like two major areas I can think of. One is the obvious areas. One is finance, and the next one obviously healthcare. So these two areas where the sensitive data are mostly being used. So in order for like when you want to like infer your data through a LLM, and you are basically outsourcing all your data, because if we use like any existing LLMs, it get trained on our own data as well. So if we want to infer a very sensitive document, and if we do it through any LLM, so we basically like giving away all our data. uh, I can actually think of like a lot of memes that showing like I'm just giving all the sensitive data from my company just to get a response email. So, uh, in order to avoid leaking sensitive information to the public, we need
Yeah.
a trusted environment. So that's where DE comes in. So these are very essential places, healthcare and finance. That is like obvious use cases to start with, and apart from this generic use cases, but this is like a very important scenarios in order to implement TEE. And other than that, there's like something like really interesting areas as well. So something like a personal assistant. So in that, like you are like sharing all your data, like not all your like life data into a LLM assistant. And so in order like in that scenario, you definitely require a TEE. So in that way, like your personal information are like not shared to the world. So that is another use case that we definitely require. And in another in as coming back to finance, but like not in like a bigger perspective, but even for like a personal assistant, which is for just finance. So you definitely require DE. So these are like the major scenarios that someone can implement. If you can like look deeper into these ideas, there's like a lot of ideas you can think of. Like just for the healthcare, if we come back, a lot of like the disease detection LLM models that can definitely utilize TEE. And coming back to like if patient data is being inferred, the TEE's utilization is very prominent. So these are like of major areas that the hackers in HyperHack can look into it. Yep, and then also like a lot of trading agents are coming up in order to make sure that execution, like for every permission, for every confirmation, it is not affected by any other external signals. We can use DEE. So this is my take on it.
Yeah, exactly. I mean, perfectly shared. the way this projects can be used, like in the finance, in this where you mentioned trading agents as well. So, and yeah, HyperHack is like in the great position to explore this further. So let's dive, like how does it actually works. Like I will be just giving actually we will be seeing the step by step flow this, because we are running like a little bit slow. So um this is what we are going to do in the live coding part. So when you what we are actually going to do is, like, we are going to save or store a very simple string on the IPFS using TEE, and we are going to use Marlin simulator for this live stream, and we can be using like Fala as well, but I will be showing you guys like what is the difference between Fala and Marlin as well. But before we go deep into the coding section, I would like you to show to see how does it actually works and what actually we are going to do. So step one is like connect to the TEE. So the client, what actually happens, the client initialize a secure session by connecting to Alith's Marlin TEE, and this enclave, like whether remote or a local. So this is a hardware, basically isolated environment that ensures end-to-end data confidentiality, and all computations from this point onwards happen inside this secure zone. So that's how it works in the connecting to the TEE, and then we prepare data. So the client prepares a transaction or a payload. For example, in our case, we are going to store like the simple string, Alice pays Bob $100. So this data is bundled with a public key, a nonce, and optionally some metadata. This forms a attestation request sent to the TEE. So that's how they prepare data and send the attestation request uh, being sent to the TEE. And then TEE generate attestation proofs on the step through, like inside the TEE. The payload is executed, and an attestation proof is generated using this the attestation hacks request function. So this cryptographic proof certifies that the data was processed within the enclave, and that the output has not been tampered with, and it is the hardware um, backend guarantee of trust. So that's how they generate the proof and run as the proof. So, and on the next step, followed step, like this, store data on IPFS. um, the output, the both like the original data and its attestation are um, are serialized into a JSON file and pushed to the IPFS. So this step makes the proof content addressable. Like IPFS gives us back a content identifier, like a CID kind of a string, using that we can which basically serves as a permanent reference to this verified state. So, and how we can verify, like how we can publicly verify this. So anyone with the CID can retrieve, like you see the link. So anyone with this CID can retrieve the this link, and um, not the link but a tested result, and independently verify the proof that okay, this is now has been stored on the IPFS, and this is working in the secure environment, the TEE. So using the TE is public attestation policy, like this brings transparency and what else we can say, auditability to off-chain confidential computation, right? So in a sense, like we are bridging secure enclave processing with decentralized storage and globally verifiability, so making it possible to compute privately but prove publicly. So this is I mean extremely relevant for the use cases like confidential what voting system or secure oracle fits and private defi logic. So this could be like really um, useful for this use cases as well. And without giving a further ado, I think we should move on to the, let me share my screen quickly. And okay, let me share my screen and show you your screen and screen. Okay, so what so in when you go to the Alith, let me start it from the first. So you go to the Alith and go to the advanced topic and go into the TEE, and you'll see here, this page. Okay, so so it actually runs on I mean you can use the Fala cloud as well as this Merlin T integration and SDK. So this SDK as well as the File Cloud, like we are going to use Merlin. And let me just give you a quick introduction of both. So first of all, like both File and Merlin are used to run core inside TEE. So the key idea with a TE is that you can run a code in a little hardware protected bubble. So and prove to others that your code really did run there. It's like giving someone a receipt that says that, hey, I didn't tamper with this result. So I mean the pinky promise, and here's the proof. So we give them the attestation result, right? So to run that environment we need SDK, right? So I mean that's why we can use like the Fala and Marlin. That's what's supported for now with the Alith. So Fala is production grade cloud based DE service. So think of it as a cloud where you can deploy your agent or application inside a real TEE like Intel SGX or TDX. So it's backed by real hardware, and that's important when you want to strong when you want like I mean the strong security guarantees that if you are running in the Fala cloud, people can trust your attestation because it's rooted in real and secure hardware, right? So the only catch is that it's a bit heavier to set up. Like you need a compatible environment, and if you're working locally, like probably you don't have a TDX server under your deck, right? So that's where Fala cloud comes in. And it's basically managed service that spins up TEE enabled instance for you. So you don't have to touch the hardware or do anything complex, like just deploy and you are good to go. So on the other side, so we are going to use Merlin. So Marlin is what you will use when you are still in the building phase. It's super lightweight and super developer friendly. So it runs locally and uses simulated TEE. So instead of real attestation coming from Intel hardware, it gives you a mock attestation like kind of like a fake proof you can test your system with. So it's perfect for local testing, debugging, and fast iteration. So you are not paying for servers, you are not dealing with real enclaves. So it's great for development education workshops like or like uh, live streams like this one. So that's why I'm going to use Merlin. Yeah. So so in the summarization, like if you want to build fast, if you test fast, and if you are not ready for a production, like use Merlin. And if you're deploying something real and you want users to trust your data or computation, use Fala. And the good news is like Alert supports both, as I mentioned previously, and out of the box. So you can start with Merlin today, and when you're ready to go live, like just switch to the Fala, and it's kind of like building prototype on a local host. And than deploying to AWS, right? So the same a different engine under the hood, basically. Okay, so let's go to the demo part, and let me share you the other screen. Do you have any question, or am I going like very fast? Sometimes I feel that I'm going very fast. I need to take like little break in between.
We don't have any questions. I think everything is clear so far.
Uh, do we have any comments, or guys, please feel free to drop comments or questions or feedback in a comment section in the YouTube, in the Twitter as well, so that we can have more engagement and more, like, we can learn more things all together. So um let's get started. So you can go to the Metis edu. Let me start from first. Okay, so you can go to the Metis edu, and okay, I'm opening the wrong one, but let me zoom in a little bit. Go to the Ripple, and we have email and IPFS. So what you are supposed to do, so we have a little introduction of Marlin and project structure. And for the requirements, yeah, you need Python 3.8 plus. If you are running like IPFS, you need this IPFS daemon running locally, go IPFS. But for this, I was having an error because my version, there was the version issuing that you need, I think go IPFS is not supported, like uh, the recent or the current version of IPFS something. So you need like the little older version. So in that case, I prefer to use IPFS desktop instead of running in CLI, but make sure that could be the version issues. So don't get like very irritated when you get this. Just use the older version and it should run fine. So just clone it, go into the repo and start the Python virtual environment, activate it, and install Alith, and to run the Marlin simulator locally. So what we are going to do, we are going to clone this. I already have cloned this. So let me open terminal. Let me make it little big. Okay. I think I do already have clone it, so it won't be running it. But yeah, but I can move to the repo. Let me move to the repo, and then where is it? Okay, go to the attestation and server custom mock. CD clear, and then just run cargo run. So as we can see, this is like our local simulator is have been started running it, and I would like to show you like what happened when it's not running, and how we can check when we run our actual code to see that if it's running on our I mean the simulator or not. Okay, so I'm getting back to that. Before, if you go here in the Alith documentation, you can see that for the local development and the testing without TDX devices, you can use the simulator available for download here. Okay, so you just gonna clone it, go into that, and just do the cargo run R, and it by default it's listening on this port, and just run cargo run, and it will start your simulator just like this. And if you see running, just keep open this in the different terminal, and go to the um, app.py file, and let me open it here. Okay, so go to the app.py file, and I don't think you need this secure demo file as well. I think we can delete it, and this is just for my purposes. Okay, so you just need this code. So in this file, what we have done, we have set up step one. We are going to connect to TEE. So with this, we're just okay. Let me just have this um, share this thing. So we are using t alith.te marlin. Okay, so to use alith TEE feature, you need the version of alith, I think 0.10 version. So make sure that you install like the recent version of alith, or else it may give you the import error. Okay, so we are just importing it, request and JSON to store the JSON file into the IPFS. Okay, so the step one to this connect to TEE. So this one is like nice and simple. So we are spinning up a connection to the Marlin server. Like by default, this is going to talk to like 1350, which is like where the Marlin MOOC server lives. So which is by default. And if you have not already started that server, by the way, like make sure it runs either on Docker or a Cargo. So if you want to run this on the different port, make sure you use this command to run on to like customize the listening in interface and port. So um okay, so and then we are preparing data. So data secret Alice pays Bob $100 and request. So this request parts are like right here, like we have got our what's it, pretend transaction. So I mean, surely like it's just a string, but imagine it's anything sensitive like medical record, a voting result, or ML model input at extra. So it can be anything. Like we are just starting in this live stream with a very basic example, but we can do like little more advanced live stream on the same TEE, this attestation thing. But to make you guys understand the real, I mean, to make you understand the real use of this TE feature, we are just going to keep it simple. So it's like it can be like anything sensitive, as I said, medical record or a voting result or any input from the ML model. So like we are wrapping that our data into a public key, not into, but we are wrapping that data into, sorry, with a public key and a nonce. So we are passing public key and user data and nonce. Okay, so think of this as a sealed envelope, and we are heading into the secure enclave. So that's first we get connected to TEE, and then when we request for attestation request, and now we are going to get the attestation proof. So in a proof we get t dot attestation hex. So we are going to get hex form of as a proof. So this is the magic. So we pass our request into the TEE, and it gives us back a cryptographic proof. So in a hex format that certifies. Yes, so this data was processed securely in a trusted environment, and we are keeping the proof short here for a demo purposes, but you would normally want the full swing, right? So once we get the proof, we are going to store um, we are going to store we are going to upload that to IPFS using HTTP API. Like if you get error, like you can just simply run this direct API call as well. So uploading to the IPFS. So now this is the right um, this right here is like how we store it on IPFS. So we create a JSON file here. So we create a JSON file with our data plus proof, and use IPFS HTTP API to upload it. And if you are running the IPFS daemon locally, like this should just work. So you'll get back a CID string kind of thing, which is like basically a hash of your content. So once you have the cid, you can share it, verify it, and publish it like wherever. So we got the cid, and then we are just printing it. So it will show the cid and the link, and we can paste that into any like IPFS gateway, and you'll see the data and the proof. So um, let me just uh, run this file, and I think I'm gonna get an error because there is some issue. Okay, so let us just run. Okay, so we get an results as expected. So we get the string that secure data stored on IPFS, and this is your CID, and T proved it, like IPFS stored it, and anyone can verify it. And how you can verify it? So you can see it here, that on this CID, because we have not created this CID anywhere in like we are not giving this CID string anyone in the code, right? So it's just creating and storing it on IPFS, which you can um, how do I say, which you can prove here, I mean verify this here. And one more thing, like when I close my simulator, like when I make it stop running it, um, it's going to give us an error that it's HTTP request, or like saying that max retries exited with URL text station. I mean basically it's saying that um, they need um, I mean, this client, this Marlin client is not running right now, and that's why it's giving us an error. So that's what another thing that shows us that it's running on that simulator. And now, someone like me might have the question in their mind that if it's running on, okay, because it's not running. Someone like me might have question in their head that if this the simulator, why don't we see any log here that are what I say, that are attestation proof or any kind of log here in the simulator? We don't see it because it's running locally, and this Marlin SDK like simulator does not print logs for the in request. So that's why it's not showing you. But if you run this the same thing on production, like using the Fala, you may see it, the logs over there. So that's the basically the simple data that where we are storing it, and that's storing on IPFS, and that's how you can verify it, that okay, your data or your code. So now this data can be anything, like it can be like your, let's say if you are running an agent, and it can be your agent input or all input and output data all together, and you can store it on TEE for any like security purposes. It can be a medical record, as I mentioned previously, and like could be anything. Okay, so while running this, if you get an error, um, if you are not able to see this what I say, this proof right here, like using this link, make sure you change the DNS of your Google, and it should run. I think because it might give you an error that not working or listening, because it's listening on the, I think, 5001 port or yeah. So make sure that you change the DNS on your Google and or the I mean the Wi-Fi network, and it should run. Um, I think that's all from my end for now. Um, if you have any questions, if you have any comments,
We have
anything, so
no questions so far, but yeah, it would be great to have a interactive session. If you have any doubts with the, we'll be glad to answer you guys.
yeah, so please feel free to drop any of questions. And before we like close this stream, we would like to have like questions in the comment section and feedback maybe, to see like how, if you guys are like getting what I'm saying or not. We'll be waiting like a few more minutes to see if anyone has any questions, comments, feedback, or anything, and we can move further. If no questions, then we can move further.
Yeah.
But as we are moving further, but feel free to reach out us on Telegram group chat or in the Twitter on the forum as well. If you have any question, if you have any doubts on integration of Alith in your HyperHack projects or in hackathon, whatever, feel free to reach out to us, and we would be happily helping you out.
Yeah, I'm pasting the Metis Laze AI developer group as well, where you can ask your questions, and one of our DevRel members will help you out.
Yep. So
Awesome.
I
Yeah,
think,
thank you so much for the session, Nidhi. It was a wonderful session, taking us all through the DE and the execution part as well.
yep. Thank you so much, everyone, as well. And for the next session, we will have like little more in advance to see like how you actually can use DE in your AI agent project, or in like any AI or the Web3 projects. So that could be like more interesting for you. And yeah, see you on the next stream. And till then, bye bye, guys. Take care.
Yeah, bye bye.